Hi, this video is on spatial patterns. By the end of this video, you should be able to recognize what a spatial pattern is and write the number pattern that describes it. So let's take a look at what spatial patterns are. A spatial pattern is just a sequence made of shapes that can be described by a number pattern. Let's take a look at a spatial pattern. Here we have some squares made up with matchsticks. We can see that a number of squares go up in a pattern. Start off at 1, 2, 3, and so on. What we want to do is relate that to the number of matches that are used in each of our patterns. So the first number of matches is 4, followed by 8, and followed by 12. Now we want to try and describe this pattern in a rule. You might be thinking, alright, let's start at 4 and add 4 each time to the number of matches. But how do we answer our question, how many matches are needed for 100 squares? I would need to know how many matches were used in the one before it, in the pattern before that, and before that. So what I want to try and do is relate the number of squares to the number of matches. Now, I'm going to try a few things. You might see what the pattern is straight away, but I might try adding 3 each time. So the number of matches might be the number of squares plus 3, and that works for the first pattern. Unfortunately, it doesn't work for the second or the third pattern, so I have to try something else. How about I try multiplying by 4? That works for the first pattern because 1 times 4 is 4. 2 times 4 is 8, and 3 times 4 is 12. It works for the first 3 terms in our pattern, so that's what our pattern is going to be. The rule is the number of matches is going to be the number of squares that we have multiplied by 4. So if I wanted to know how many matches would be needed for 100 squares, I would do 100 squares multiplied by 4, which is 400. But what about a spatial pattern where it's slightly different? Here I have the same number of squares in my pattern, 1, 2, and 3, but the number of matches that are used in each of them changes. In the first term, I have 4 matches. In the second term, I'm only using 7, and in the third, I'm using 10 matches. So what might my rule be? Now, it might be just to start at 4 and add 3, and that would be okay if I was going from left to right with my number of matches. But that still doesn't answer the question, how many matches are needed for 100 squares? So I'm going to try and relate the number of squares that I have to the number of matches. Now, looking at my last pattern, I might just think it would be top multiplying by 4. But that rule has to work for all of the numbers in my pattern. So it doesn't work for the second one. So therefore, it can't be the number of matches equals 4 lots of the number of squares. So now let me try something else. Maybe it's plus 3. But I can't plus 3 to get my second number in my pattern. So that's not going to work. Why don't I try a combination of multiplying and dividing? Maybe I multiply by 2 and then add 2, because that works for the first one. 2 times 1 is 2, plus 2 more gives me 4. That works for the next one. But if I do 2 times 2 is 4 plus 2, that gives me 6. It doesn't give me 7. So that rule doesn't work for the second one. Let's try multiplying by 3 and adding 1, because that works for the first number. If I do 2 times 3, that gives me 6, plus 1 gives me 7, that works. And 3 times 3 is 9, plus 1 gives me 10. I think I've found my pattern. So the number of matches, that's the number down below, is going to be 3 lots of the number of squares that I have, plus 1. This also answers my question, how many matches do I need for 100 squares? It'll be 3 times 100, which is 300, plus 1 more, 301 matches. So what should you write in order to get something down for this video? Sorry. We definitely need to draw up some of the spatial patterns, as well as how we found our rule, and then try drawing up the second number pattern as well, seeing how it differs from the first. And that's it. Hopefully now you know what a spatial pattern is, and you'll get some good recognition of different types of spatial patterns when you work through your text tomorrow. Good luck.